Okay, next we'll discuss about mass storage devices. A mass storage device or MSD is an storage device that makes it possible to store and port large amounts of data across computers, servers and within an IT environment. Mass storage devices are portable storage media that provides a storage interface that can be both internal and external to the computer. A mass storage device may also be referred to as an auxiliary storage device, and the term is commonly used to describe USB mass storage devices. Mass storage is distinct from memory, which refers to temporary storage areas within the computer, and unlike main memory, mass storage devices retain data even when the computer is turned off. We can divide mass storage devices into these groups: magnetic storage devices, optical based devices, solid state devices, hot swappable drives. First we'll discuss about magnetic storage devices. Device which store digital data in magnetic media. Computer systems need to store data in digital format. One of the most widely used types of digital data storage is magnetic storage. This refers to any type of data storage using magnetized medium. Digital data consists of binary information, which is data in the form of zeros and ones. There are two types of magnetic polarities, each one used to present either 0 or 1. Non-volatile memory like RAM, magnetic storage is a form of non-volatile storage. This means that the data is not lost when the storage device is not powered. This is in contrast to volatile storage, which is typically used for main memory of a computer system. And read and write heads are used to create magnetic patterns in the media. Read and write head moves very close to the magnetic surface. The distance is often no more than tens of nanometers. The head is able to detect and modify the magnetization of the material. The magnetic surface is divided into very small regions, each of which has a mostly uniform magnetization. As the head moves relatively to the surface, the changes in the magnetization from region to region are detected and recorded as zeros and ones. We can divide magnetic storage devices mainly into three groups. First, floppy disk, hard disk drives and tape drives. We are not going to discuss about these floppy disk because now these are not very common. So first we'll discuss about hard disk drives. Most popular mass storage device, a computer hard disk drive or HDD is a non-volatile memory hardware device. Therefore, HDD retains its data even when power off. Hard disk drives are commonly used as the main storage device in a computer. HDDs often store operating systems, software programs, and other files and can be found in desktop computers, mobile devices, consumer electronics, and enterprise storage arrays in data centers. It is usually installed internally in a computer, attached directly to the disk controller of the computer's motherboard. Internal hard disks reside in a drive bay connected to the motherboard using an ATA, Sci or SATA cable. They are powered by a connection to the computer's power supply unit. External hard disk drives. Most HDDs are found internally in a computer and work as stated above. However, individuals can also purchase external hard drives. External hard drives are used to expand the storage capacity or act as a portable place to back data up. An external hard drive can connect to a computer or device using a USB 2 interface or with eSATA. External hard drives may also have slower data transfer rates compared to internal hard disk drives. Hard disk drive components and how it works. So we'll see what are the components of a hard disk and how these components work. Hard disk drive is a data storage device used for storing and retrieving digital information using rapidly rotating disk or platters coated with magnetic material. Most basic hard drives consist of a number of disk platters that are positioned around a spindle inside an air-sealed casing called as chamber. The chamber also includes read and write heads or a magnetic head which moves rapidly over the platters as they spin, and also inside the chamber we can see motors. Platters are the components which holds data and the motor is used to spin the platters. This rotation is done up to 15,000 rotations per minute. Obviously, a higher RPM number of results in faster performance. As the platters spin, a second motor controls the position of the read and write heads that magnetically record information to and read information from the tracks of each platter. So, as you can see in this picture, a hard disk consists of a number of platters and data is stored in tracks of each platter. A stack of platters connected through a rotating spool called spindle, and each side of a platter is able to hold data as each platter has read and write head in each side. And a hard disk can also hold data up to terabytes. The hard disk in and of itself cannot directly communicate with the CPU. Communication of the hard drive with the computer depends on some components. The first one is the controller, which links the drive to the computer, and then we have host bus adapter, which converts the signals used by the hard drive to those used and understood by the computer. The disk interface is the connection of hard disk and host system. The function of this interface is transfer data between hard disk cache and host memory. Different hard disk interfaces have different connection speed between hard disk and computer, and in the whole system, the quality of the hard disk interface affects the operating speed and system performance directly. Hard drive interface is mainly classified into four groups: integrated drive electronics, enhanced integrated drive electronics, small computer system interface, serial advanced technology attachments. First we'll see what is this integrated drive electronics or IDE. IDE was the first interface to actually embed the controller with the housing of the hard drive itself. Because of the integration of the hard drive and controller in one unit, the cost of the drives also came down. Along with its improved performance has made the IDE drive a very popular selection for most personal computers sold today. The IDE interface only requires a single 40-pin control and data cable which connects the hard drive to the actual system board. Enhanced integrated drive electronics. The IDE interface, which could only support drives up to 540 megabytes, has been replaced by the superior IEDE or Enhanced IDE technology, which supports over 50 GB and allows for over twice as fast data transfer rates. The hard drive interface that succeeded integrated device electronics or IDE, also known as ATA or ATA1. The interface acts as an intermediary between the computer and a mass storage device. Small Computer System Interface SCSI. SCSI device that connects to the cable must have a unique address. This is what makes it possible for multiple SCSI devices to work together. IDE interface is the standard interface of common PC, while SCSI interface is not specially designed for hard disk but is a high-speed transition technology which is widely used in small-sized machine. SCSI has many advantages, including wide range of applications, multitasking, wide bandwidth, low CPU occupation rate, and hot swap ability, and so on. But the higher price makes it difficult to popularize as IDE hard disk, so it is mainly used in medium and advanced servers and advanced workstations. Serial Advanced Technology Attachment or SATA. Serial ATA is a novel kind of hard disk interface which is totally different from parallel ATA. It is famous for applying serial mode in data transmission. Compared with ATA, SATA has many advantages. Firstly, SATA transmits data in the way of continuous serial and only one digit data can be transmitted each time. Serial ATA uses only 7 wires to connect the device with host adapter. Serial ATA uses a special encoding method to ensure fast data transfer with the device. The current standard allows 150 megabytes per second data transfer, faster than typical IDE data transfer rate. Future SATA standards are proposed to transfer up to 600 megabytes per second. The yellow SATA cable speed has a data transfer rate of 3 gigabytes per second, and red SATA cable speed has a data transfer rate of 1.5 gigabytes per second, and normal P4 motherboard supports 1.5 gigabytes per second SATA support. Tape drives. According to studies, that the amount of data being recorded is increasing at 30 to 40% per year. Modern hard drives, which are used to store most of this, is increasing at less than half that rate. But much of this information doesn't need to be accessed instantly, so for such things, magnetic tape is the perfect solution. And indeed, much of the world's data is still kept on tape, including data for basic science such as particle physics and radio astronomy, human heritage and national archives, major motion pictures, banking, insurance, oil explorations, and more. Although tape doesn't offer the fast access speeds of hard disk or semiconductor memories, still the medium's advantages are many. That is, tape storage is more energy efficient. Once all data has been recorded, a tape cartridge doesn't consume any power at all, and tape is also exceedingly reliable with error rates lower than those of hard drives. And it's cheap, and it's getting cheaper all the time. Tapes have a high storage capacity and are portable. Therefore, they provide an efficient way of storing and transferring data. Tape drives are used primarily for file system backups and restoring file systems or individual files. Uses a magnetic data tape cartridge that must be stored in sequentially, hence a slow read-write speed. Used digital linear tape or DLT technology and now improved to SDLT or Super DLT technology. Here you can see the tape drives. So next we'll discuss about optical based devices. Optical based devices have three major types: compact disc, DVD and Blu Ray. First we'll discuss about this compact disc or CD. CDs are cheap, light, robust, user-friendly, computer-friendly, mail-friendly, and most music buyers have a player. Capacity is about 700 megabytes and stored data in a format of ones and zeros like hard disk and floppy disk, and it uses laser beam to read and write, unlike magnetic energy in hard disk or floppy disk. And advantages of using laser beam are no physical contact between CD and reading device, and diameter of laser beam is small and makes storage tracks written very closely, data stored in a small space. Here these are the types of CDs: CD-ROM, CD-R and CD-RW. So CD-ROM is on read only, and CD-R we can record but only once, and CD-RW recordable, and we can record it many times. Here we have data transfer rates. As you can see here, 12x means data transfer rate is about 1800 kilobytes per second, and 52x means data transfer rate is 7.2 megabytes per second. Then we have DVD. It is introduced around 1995 and 1997. Stored digital sounds, videos and data, and can be recorded on both sides, and it uses red laser. There are two types of DVDs: DVD-R, which is recordable only once, and we have DVD-RW, which is rewritable. Then we have Blu Ray, introduced in 2006. Stored HD or high definition video, audio, photos and data. Single layer stores up to 27 gigabytes and double layer stores up to 50 gigabytes. And it uses a blue laser and plays data on the top of a 1.1 millimeter thick polycarbonate layer. Here we can compare the writing of CD, DVD and Blu-ray. Both CD and DVD use a red laser to write, and Blu-ray uses a blue laser. And the track pitch becomes smaller when moving from CD, DVD to Blu-ray. So next we have solid storage, also called as solid storage drives and SSDs. Another non-volatile memory storage and stored data electrically instead of magnetically. And we have external and internal SSDs. Internal SSDs used in mobile phones, sophisticated network devices and GPS systems. External SSDs are used as flash, thumb, pen drives and card slides. Here you can see internal SSDs and external SSDs. So finally we are going to discuss about hot swappable drives. Hot swappable drives can be connected or disconnected without shutting down the computer system. So it requires special trays for that. Used to keep servers always up and running even if a hardware alternation needed to be made. Used mostly in hard disk arrays with redundancy array of independent disk. So this is all about internal parts of a computer system. Thank you.